Living Room Logic. Welcome to Living Room Logic, a place for you to chill out and have a laugh with two scientists who know too much about very, very little. Andrew is dying to get into your head, but I will have you sleeping with the fishes.
This episode, we describe the many ways life has died on Earth, why Mother Nature has menopausal hot flashes, and how the dinosaurs got wrecked by a Mexican space pebble.
Make a huge impact and follow the podcast on Spotify or Apple Podcasts. Come find us on Instagram or Twitter or other social media where you catch up on the latest from rip.ie. Sit back and enjoy this depressing dialogue.
All right.
Beautiful sound again, Andrew. Oh, can I just say?
A cracker. Way. Welcome to this week's podcast. I'm Andrew McGovern and I am with
Aidan Long.
Okay, and we are going to talk about stuff that we don't really understand, but we sure are interested, and that's all that matters, right? That's what counts. That's
all that matters.
That's what counts.
We keep saying this every week, and you'd swear we'd learn something.
Yeah, you'd think. Well, we do learn something every week. We cram it before we start recording, and then then we talk about it with confidence. And if you talk about it with confidence, it'll get you far, and that's our ethos. So this week we're going to talk about something really fun and really exciting, and something that's really thrilling. We're going to talk about death. Aidan.
That's your segue?
Yes.
I love it. So today, everyone, we're going to talk about dying. No, we're actually going to talk about great dyings.
Oh, great dying.
Known as... great dying.
That's an oxymoron if I ever heard one. It's like, oh, you were dying? I hope it was great.
Yeah, it was great.
It was a good time.
Yeah, so these great dyings are also known as mass extinctions, and there've been several of these mass extinctions or great dyings in Earth's history, but weirdly enough, they've only really been quite recently, and recent is a relative term in terms of the age of the Earth, which is about 4.5 billion years, or in other terms, 4,500 million years, if that makes it any easier to understand. But the thing is, and it's a really crazy point to make, is that over the course of life on Earth, there have been about 4 billion species. Again, 4,000 million species. So relative.
Wow. So relative. So relatable. Relative. That's how many problems I've had today.
4,000 million. Thing about these is that actually 99% of those 4 billion species have already died. So today, there's only about 1% of the species that have ever lived alive today, which is pretty crazy. So we're this 1% of really lucky dudes.
Yeah. It's always the 1% who, get to survive and, have a good time and have a good existence.
We're actually part of that terrible 1%.
Oh my God.
The ones that just keep persevering.
The ones I keep getting told by media to hate. Those ones, I hate those, the 1%.
Especially, yeah, they're us.
Damn it.
So, well done to us for surviving this long. I think we actually deserve, a celebrate. This is a celebration. Well done to all of you out there and all the animals in the world. You are the 1%. You have managed to survive for about 3.5 billion years, or at least your evolutionary ancestors have.
Damn right.
And that actually brings me back to kind of giving us an idea of when these mass extinctions have all happened in the geological timescale. And what that means is that I'm trying to relate to you how actually long it takes for life to evolve and for these things to happen. So the Earth is about 4.5 billion years old, as I said. If we're to cram those 4.5 billion years down to a single year, a single calendar year of 12 months, life evolved in March. The Earth was, started in January and life evolved in March. It took another 8 months, or twice as long as it took for life to evolve, for these mass extinction events to actually start occurring, or at least for us to find them in the geological record. So where those mass extinctions start is not in March. It's actually right near the end of the year in mid-November. Okay? So about 500 million years ago. So there was a long time in between where there wasn't a lot of species. There were some weird and wacky ones, which we can talk about another day, but they're kind of weird, and there wasn't a lot of them. But then there was this explosion of life and species in this era known as the Ordovician. And the Ordovician era ended in about 450 million years ago. And this is when that first great dying happened, when all hell broke loose and pretty much all life was freaking out. And they freak out a couple more times.
That's relatable.
But during this... I can relate to that. During this Ordovician mass extinction, bad things happened. But before I get on to the mass extinction, maybe I'll talk about what sort of life was alive during the Ordovician. I actually, weirdly enough, did some research on one of these animals that was alive during the Ordovician. It was this little weird worm-like, but it was like a huge worm called a conodont.
Okay.
And it had no backbone, and it had an absolute shit ton of teeth in its mouth. Okay? It was like all teeth, just buck teeth, like just these elements called appetite elements. Mm-hmm. And they preserve in the fossil record. And so all we've really been able to find is these weird teeth, and we finally found a couple of these perfectly preserved actual with the whole long, slender, ribbon-like body. But there's only about 10 of those in the world. And I'm going to bang out another German term for you, because why not? Last week I had... Umwelt.
Yeah, you love that.
I don't know. I don't even speak German, but I like it. This term this week is Lagerstätten, and it means storage space. And it just means that... Thanks, Germans.
You know, last time it was so interesting. Umwelt. It was like the surrounding world and your perception of everything. And now you're like, yeah, this one's like your cupboard. It's a storage space, you know.
This is a storage space to die in, okay?
Okay.
That's what a Lagerstätten is. It's like the perfect place for an animal to die, to become preserved.
Well, now that's even depressing.
Yeah.
Oh.
This episode's sad, okay? If you don't want to listen to it, go listen to some happy stuff, all right? We're talking about death here. So, the Ordovician had these conodonts. There was very early versions of coral reefs and other really weird types of... they kind of look like horseshoe crabs. They're called trilobites. And they actually had eyes and they had antennae, but a good point is that everything was marine. Everything lived under the water. Nothing had evolved to move on land yet. Okay. So everything's having a great time, and then boom, okay, things start happening.
Okay.
In the Ordovician, the sea level was about 600 meters higher, so a lot of the land was in the southern hemisphere, and there wasn't much of it. Most of the earth was covered in water, and what happened was a mountain belt was created in the landmass in the southern hemisphere which is now the Appalachian Mountains, and you might know that from the Appalachian Mountain Trail in America. Cool. But the thing is, when those mountains were raised, it actually weathered really easily. So acid rain and other natural phenomena kind of broke down these mountains really quickly.
Mm.
And it caused a severe lockup of CO2 into the ocean. And a drop in CO2 levels actually caused global cooling.
Mm-hmm.
And then you get massive ice caps forming on both hemispheres, on the southern and northern hemisphere. And then you get a super severe drop in sea level. And all of these dudes hanging out in shallow waters are basically forced to move to deeper waters where they all die. And it was several of these up and down events of sea level rise and sea level fall, global cooling and global warming after, that pretty much killed about 85% of species. So that's one thing I should say about a great dying, is that more than 75% of species have to die. More than 3/4 of all the species on the earth have to die. So it killed all of these kind of early dudes, right?
Mm-hmm.
And it actually left, the ones that survived were the earliest versions of fish, and that kind of came into the new era, which is known as the Devonian, which is the age of fish. And I think Andrew might know a little bit about the Devonian.
Yeah, just about. But
a little bit.
Just a tad. Not quite a tadpole, just a fish. Yeah, no, the Devonian period I think it's cool. It was about, it wasn't quite last week. It was about 416 million years ago, something like that. Ask your mom; she might remember. It was back. It was a while back in the day, and we were.
You just insulted everyone's mom.
Shh! No moms listen to this. And if you do, God bless you. You're a great creature. God bless you.
God bless you.
Anyway, yeah. So during the Devonian period, it was really interesting. So you had the supercontinent in the southern hemisphere that you mentioned called Gondwana, which I think is an excellent name for any place. Gondwana.
Gondwana forever.
Gondwana. Well, not forever. It ended. And you had another supercontinent at the equator called Euramerica. So that was quite imaginative, and I'm sure you can kind of imagine what was involved in that, but it was more so South America, because at this point in existence, the North America was submerged underwater, the majority of it, except for the mountains that were poking out of the water. So North America housed a lot of the shallow waters that Aidan mentioned.
Mm-hmm.
And the life during the Devonian period was pretty cool. You had your first reefs, you had all these fish and sharks and rays were developing, and you had these things called placoderms, which were the main predator of the ocean. So now you kind of think, the great white shark, or getting attacked by a giant squid. At the moment, they'd be like the apex predators, but you had these placoderms who had these terrifying jaws that would just crush things, and they were just anything that would run in front of them, they'd eat. They remind me of, do you ever see the videos online of the gas crusher or whatever it is, and they just put something random.
Oh yeah, the pressure crusher.
And they just put something random into it and just look what this looks like when it explodes from pressure. That's what these fish were like. These fish would just walk around with their giant faces and their giant jaws and kill things.
The weird thing about placoderms was that they were completely armoured with this weird bony plates. That's what they were known for. And you said their whole mouth is just like two plates of not even several teeth. It's just one plate in the bottom, another plate on the top, and they're both serrated.
Yeah.
So it's just one crazy crunch.
It's a crush. Well, at least it's a quick death.
It's a quick death.
Yeah, you don't... There's no the pain, he's ripping off my arm. No, it's gone. It's just, you're gone. There's no... They don't play around. In this age of fishes, though, it was also kind of the beginning of trees on Earth. And you had the first ancestor of the conifer tree kind of came about at this time on land. And they had no competition, really. And they would proliferate like mad. They just keep making little tree babies, or as normal people would call them, seeds, and keep making more trees.
And trees covered the whole place, did it?
They covered the whole world. The whole world. And
all of land.
Produced all of land. Just one pine tree coming out of the middle of the ocean is a great image. Just how did this get here? But on the Earth as well, this was you had the beginning of insects around this time. You had the 2-meter long centipedes, which is,
oh my god, no.
Yeah, big time no. No, this is...
I talked about how the centipedes are bastards, right?
What do you mean?
In the last episode about insects, episode 2.
I think you did, yeah. But
centipedes are evil bastards, just FYI.
Just, you should probably go on.
There's nothing else to say.
Nothing else to say? You don't want to... Okay.
Elaborate.
Go check it. Go check it out if you want to know why those centipedes are bastards. I just think the wriggliness of a centipede is just something that you don't want to exist. Okay, but you also had the first amphibians around this time. So you had the first kind of the first fishes trying to come onto land and do something before going back to the water, which is kind of cool. So you see a lot of in this period, you see the start of quite a lot of life that we recognize today. Like you have your first kind of plants and trees really popping up. You have all these insects. You have things coming onto land, which is cool. Except one problem with the trees was that they had no competition. And a big thing that they did was they made so much oxygen. And today that would be fab. You know, that'd be lovely. Except what happened was they took so much oxygen and they sucked in so much carbon that it messed up the ocean, and things weren't happy. It screwed
with the atmosphere, right?
Yeah, it screwed with the atmosphere, and there was a huge depletion of ozone. And there was, it's a crazy thing going on, because that's the main theory, right? That there were so many trees and there was so much oxygen produced that all of this oxygen messed up the balance, and there was no carbon, so things couldn't exist. You need carbon to exist because the trees would just pull it in and put it in the ground. And they were saying that caused the extinction, but we're talking like 350 to 415 million years ago. So there's actually a lot of discussion around this. And I found it, when we were reading about this, I found this to be one of the most interesting ones, because there are so many theories. So a big one was that the ozone layer depleted, right? And what a group of scientists said was that maybe there was a supernova that seriously now, that there was like that shot the equivalent of solar flares, which blew the ozone layer off. Okay, but
so supernova, for anyone who doesn't know, is when a faraway star explodes, right?
Yes. Or any star explodes, but not our star, because we wouldn't exist anymore.
We love our star.
We love our star. It's the best. But so they were saying that this supernova could have blown the ozone layer off, right? And then all the ultraviolet light, would kill everything on Earth, the equivalent of giving everything on Earth a sunburn until it all dies. And this theory is quite prominent because they can time a supernova to that time period.
Oh, weird.
Yeah, so when that extinction roughly happened, and it all kind of adds up. And they're looking in the fossil record, they just need to find the presence of these radioactive thingamabobs, these radioactive elements in fossils at that time, and they can be like, oh my god, it actually was a supernova.
Oh, yeah. Okay. And it's usually, with these mass extinction events, it's usually several things happening at the same time, right?
Absolutely, like a big grouping of these bad things happening. Like there's another side of it as well, where we're talking about all this oxygen, and there could have been a cooling and a acidification of the ocean, but there's also the possibility of a magmatism, right? Because it was around this time that these two supercontinents started coming together to form Pangea, which was like the supercontinent that you hear about when all land on Earth was just one big circle and 85% of the globe was ocean. But it was around this time that these supercontinents started colliding. And well, when two supercontinents collide, it'll make volcanoes and mountains and generally cause a little bit of a mess. But they were saying that it could...
just a little bit.
Yeah, just a tad. Like, it's less than ideal. But like, this could have produced so much CO2 and so much sulfur dioxide that it again would have thrown off the balance in the atmosphere, which could have led to this mixed effect of having this extremely high amount of oxygen, this then foreign CO2 coming back into it, but it's no longer in the oceans, but it is in the atmosphere, and then you have this sulfur dioxide coming in, messing everything up. It appeared to be a bit of a cluster of nightmares happening all at once, less than ideal. And the thing is that they don't really have an exact finger to point at it,
Yeah, but the major culprit is probably the fact that all of them happened in a similar time frame.
For sure.
And I think another cool thing to mention is when you said that this mass extinction happened, some people think that that's actually kind of what pushed some of those kind of semi-aquatic beings, semi-aquatic reptiles, to move onto land.
Yeah, I read about that too, and I thought that's very cool, and it makes total sense because there was more oxygen in the atmosphere than there was in the water. That was the problem that was going on. So the animals that could adapt to actually develop this ability to take in oxygen, they were grand. No bother.
You know that a really cool thing about that is that there's actually one of the most famous fossils from that time period when this semi-aquatic being called Tiktaalik was making its way onto land, and it would kind of take longer and longer periods out of the water. It did this on a shale that is off the southwest coast of Ireland.
Really?
Yeah, so there's some amazing footprints that are in the southwest coast of Ireland that they date back to that time.
That's amazing.
So it's when these weird looking half fish, half reptile dudes were kind of squirming off onto the beach and scurrying up and getting a bit of plants into their bellies and then heading back in the water.
Man, that's so cool. Han
the Tiktaalik.
Han the Tiktaalik. Yeah, that's so cool.
So that's our massive claim to fame, Andrew.
Is that Ireland's only claim to fame? We got out of the water first. Ha, ha, ha. Damned be to the rest of you.
We did it.
We'll go back we swear.
Ireland definitely wasn't in the same place, but we don't care.
Look, we were the first to stop drinking the water, and we've been drinking ever since. You know, it's the grand circle of life. We're just going full circle here. Don't judge us. We're just going full circle. I think it's kind of
funny how our accents just got very Irish there.
Yeah, well, you know, that happens when you get a bit of national pride going.
That's right.
You know.
So, Andrew, do you know how many species died, like the percentage-wise?
I'd say somewhere between a lot and a bit more than a lot.
About 75% died this time. So, again, 3/4. It's crazy the amount of species that are getting killed off in these things.
Yeah.
And then another cool thing about it is that those Tiktaalik evolve into something else and they move on. And then after this mass extinction, it kind of pushed things onto land. And that's when you start getting these really cool land animals. And that brings you through several eras into what we know as the Permian Era. And the most interesting thing about this is that this is one of the biggest mass extinctions, if not the biggest one. It was about 250 million years ago, so we're coming closer and closer to today, but still very, very far away. And the sort of animals that you would have at that time in the Permian, it's about 100 million years after the Devonian. You have these really weird hybrid species that are kind of somewhere between a reptilian and a mammal and something else. They're confused, Andrew. They're confused.
Oh, relatable.
Okay.
Relatable content.
You have like these models of these things called synapsids. They were like these several meter long tiger reptiles. So they were like, they filled the niche, like they filled that predatory niche of a tiger, but they weren't. And they had these large teeth and kind of big, not canines, but they had large teeth where canines would be in dogs.
Wow, yeah.
And they were just huge. And one thing about this Permian era is that oxygen levels are super high at this time, okay?
Okay.
So everything's huge on land. You got these really big things in the water. You have this thing called Helicoprion, and it's one of the earliest sharks to evolve. And this thing is so weird, Andrew. It had its lower jaw had a spiraling buzzsaw in the middle of its mouth. So it was like vertical and it looked like a buzzsaw. And the teeth, when the teeth, after it biting something, some of the teeth can fall out. So it's like a spiral that's underneath and inside, and then those teeth grow out.
That's
once
messed up.
The ones that, once they get used. And so what it would do is it would actually get its prey and like whack it off the roof of its mouth, and it would just split the prey in half.
Man, that's weird.
So weird.
That's
why?
so weird.
Why, Mother Nature? Why would you do this?
Oh man.
But anyway, that happened. She mean. All right, that happened. That was scary. Okay, so during this time, you actually have a massive amount of species on land. You have all sorts of plants and insects, and you can see that it looks a lot like land today, except for those weird freaky hybrid reptile things called synapsids and co. But the biggest mass extinction happens. And this one's actually known as the Great Dying. The worst one of all time. 95% of species were killed off. 95%.
That's messed up. 95?
Only 5% of species survived, okay?
Wow.
And the crazy thing about this one is that the rest of the mass extinctions that have ever happened were several million years in the making. There would be these kind of rise and falls of sea level. There might be changes in temperature or what have you. But this one is 50,000 years.
That's nuts.
So very short in a geological timescale of what we were talking about earlier on. And the main culprit of this is actually a huge magmatic province, or basically a huge area of volcanism opened up on Pangaea, in a place which is now Siberia.
Wow.
And pretty much all of Siberia, the entire country, is covered in this thick layer of basalt.
Wow.
And that's from lava that opened up during that time, right? In that 50,000 year period.
Mm-hmm.
And the amount of carbon that it released into the atmosphere, Andrew, it's crazy, okay? The way that they explained it was, if humans burned all of the fossil fuels on the earth today, the amount of carbon that was released in those 50,000 years were 2.5 times more than that.
Oh my God.
So basically you get this...
That's crazy.
Incredible change in the atmosphere, where
God.
it's like global warming on crack, okay? The atmosphere is so full of carbon, and it's so full of things like hydrogen sulfide and toxic poisonous gases, that all land mammals are just dying off. You're getting these crazy wildfires where like almost all of the forests in the world at that time on Pangaea are burned to the ground. The entire Pangaea landscape is covered in charcoal. And the weirdest thing about this mass extinction is, in the rocks, in the geological record, there's this thing called the charcoal gap. It's one of the only things that have ever happened in the world, that you can look at anywhere in the world at, the end Permian time, 250 million years ago, and there will be this thick black layer. And that's what happened to all the trees. They all burned down. Wildfires everywhere. Crazy. Like hellish stuff, right?
Wow.
The ocean was so hot that in the equator, it was 40 degrees Celsius. It was like a hot tub.
Wow.
So this is just... Nothing would have survived in terms of like larger animals and stuff. Nothing would have survived at 40 degrees.
40 degrees?
40 degrees Celsius, yeah. 40.
Sure, that's happening today.
No, in terms of like ocean temperature,
the
ocean temperature is nowhere near... Sorry, ocean temperature,
oh my God.
Yeah, so sorry, I should make that abundantly clear. The water was like a hot tub at the equator.
Crazy. 40.
All right, so...
That sounds great
you
for a
can hop
holiday.
in and have it sounds wonderful. But then to get, a holiday is that you'll come home after.
True.
And then you find out that your entire landmass is covered in charcoal. But yeah, and the weirdest thing about this is that there was a weird change in the Earth's magnetic field at the same time, and that happened from all the volcanism that was happening. There was this massive province that was subducted, which means that it dropped down into the Earth's magma underneath the crust.
Wow. And
it caused a huge change in the magnetic field of the Earth. And all of this stuff just created this hellish scenario where 95% of species were killed. And, apparently it took about 10 million years for animals to properly get back. Plants got back first, and things like fungus and stuff, mushrooms and stuff like that, they bounce back fast, but animals and marine animals took millions of years, 10 million years even.
Wow, that's nuts.
So, but the positive thing, again, about the end Permian mass extinction...
Do tell me what makes it great.
It let our most common ancestors, again, it paved the way for them to evolve.
True.
But before mammals and vertebrates and... mammals evolve, you get the Triassic period and dinosaurs and stuff like that.
Yeah.
So, Andrew, tell us a bit about that.
So, it was interesting. Like, well, you know, the Great Dying was a little bleak, but there was a few little creatures that survived, and it tended to be the smaller creatures, the creatures that could like find a little cubby hole when things got bad, or that didn't need a lot of oxygen. You know, the bigger the creature, the more oxygen you need. If the world is full of hellfire, you're gonna, you know, it's a less than ideal scenario. You know.
It is. It's not the best.
Yeah. So so this was the Triassic period was kind of the age of dinosaurs, right? This is when they came into their own. Like once the Permian had kind of settled down and all of that, the Pangaea was mostly a desert. It was just a barren landscape. It was long and wide. There was definitely no ice caps after this thing happened. You know, they gone. And the Triassic period was a funny one because it was kind of trapped between two extinction events. It was quite like you're saying 50,000 years, like that's extraordinarily short, and this is a 50 million year gap between extinctions. Yeah. So it's saying that after such a, you know, huge event, 95% of things are wiped out. This is like the 50 million year recovery time before, you know, the Earth relapses back into death. You know?
Earth, why do you keep relapsing?
Why are you doing it? You know, there's no like Earth support group for stop killing your animals. I can't help it. You know,
Venus is just like, hey, calm down, baby.
chill, girl. Just accept it. You know, be like me. but what was cool about the Triassic, right, was that it was really the survivors, right? So you had like all of the things that could survive had all this opportunity to evolve into new niches of life, right? There was no more big predator, so small things could become big. You know, if you were a small animal, like a lizard, that used to, every time it used to go near a tree or a plant, it would get picked off by something else, that's no longer a problem. It's dead. So you can now go and do all those things. And like so much of the stuff so many things in the ocean died that we had actually reptiles actually went back into the ocean. So that's where you get your I'm probably going to say this wrong, but your Ichthyosaur, like yucky Ichthyosaur, or is it Ichthyosaur? I'm not sure which.
Ichthyosaur.
Wow, I was wrong. But the Ichthyosaur anyway was like this marine reptile that went back. Yeah. And these reptiles were so cool. Like you had the Archosaurs that evolved from these itty bitty little reptiles that were like, I can just keep getting bigger until I become the man, the apex predator. And like one of them, right, one of these Archosaurs turned into a crocodile that stood upright and was 6 meters tall.
Oh my god.
Imagine that.
This is huge.
That's crazy. A crocodile. It's mad that it stood upright to begin with, but 6 meters long. Like, that's crazy.
Why, like?
Oh, dude, don't ask me. I don't know. Just because it could. That's how evolution works. If it can, it will. You know, what kills things off is when it can't do things, when you can't eat.
Crocodiles, they're some resilient dudes, aren't they? Like, they've gone through a lot.
Yeah.
They've gone through... So you're telling me that, like, early ancestors of crocodiles were back in the Triassic, like, 200 million years ago?
Relatives. Distant relatives. But, yeah, they're a sturdy build.
And they just don't care. Like, nowadays, like, they're still just hanging out looking like absolute dinosaurs in the feckin' rivers. Like, they don't care.
Rivers, talk about golf courses. Every other video coming out of Florida is these rich people on their golf courses, and they're like pause as a crocodile just slowly makes his way across.
Yeah, that's only in Florida. They're just like, God damn it, there's another crocodile.
Oh no. The Everglades are a cool place. But like, that's so cool. And then, but like these Archosaurs, right? These little reptiles that saw the Triassic period, and they're like, we can do it, guys. Like one grew up, one family grew up to be this 6 meter tall crocodile. Another one grew to be this Coelophysis. which is like a distant relative of the velociraptor, right? They were fast, they were kind of small, and they hunted in packs, which is also mad cool, right? And you also had the first pterosaurs, which are the flying dinosaurs, right? Like there was some that were like the size of crows. You also had the gliders, you know, like we still have gliding reptiles today that would jump from tree to tree, etc., etc. But to kind of like, you know, we want to talk about, you know, it's all me, talk about me. The earliest mammals also came out of this. Right?
No way.
Yeah, the earliest mammals.
Here we are. What are we doing? We're probably like digging holes and eating worms.
Well,
and stuff.
we were like, let's go hibernate for 50,000 years. And when we looked up for half a second, it was like, oh my god, what happened? And but we were like, hey, all the things that were trying to kill us are gone. Neat.
Oh, great.
That's nice. You know, I like. There was these. They were relatives of. They were like came from the same place as reptiles, right? They were herbivores and insectivores. All they could really do at this point was, you know, eat some leaves, eat the insects that didn't survive the Great Dying, and they kind of looked like shrews. Yeah. They still laid eggs like their reptilian cousins, and their young suckled, which is kind of cool, you know?
Okay, so it's like a weird somewhere in between. Yeah, that's so cool. Yeah,
and then everything died.
Oh my god, I forgot we were talking about death.
Yeah, let's go back to that. So 50 million years of all this cool stuff developing that had all these mad things and all this cool evolution going on because there were so many different like niches that an animal could evolve into. Then similar to last time, the splitting of Pangea happened again. And and this altered the oceanic pH again, and there was a huge increase in land temperature as well. And so a lot of this was saying that there was an increase, a global warming again this time, right? And they're not sure whether or not it was a natural global warming, so it just kind of a passive global warming, and they're saying that it's between there being a volcanic global warming that altered the ocean pH, or that the general global warming melted the permafrost, which released all of the methane which had been caught up in all of the previous disasters. And like, if you think of CO2 and like CO2 causes global warming, methane is like, screw you CO2, I'm CO2 on steroids and I'm gonna beat up this earth. Okay, it's like it's 4 or 5 times worse for global warming. So if all of the methane got released from the permafrost, earth get hot quick. So after the Permian it was really hot, it began to cool and it started to get hot again, and it was like no, and well, things died.
And it makes sense, like the idea of Pangea breaking up. I think that was actually when the North Atlantic Ocean, all of that province, that crust was made. And so it makes sense to make crust. What do? You yeet a bunch of lava and magma up through the middle of Pangea and you create an ocean basin. And so all that volcanism that's where it originated, I think, during that time.
It's still a bit rude though. Like, it's kind of like one of those things. It's like when if you get a letter in the letterbox and it's like, by the way, we're going to be knocking down this building next door to you and building a new one over the next 6 months, starting tomorrow. Maybe buy some earmuffs or something. It's like you know, it's less than ideal. It's
by the way, we're gonna split Pangea in half, and we're gonna make a massive new ocean, and we're gonna call it the North Atlantic. You might experience, you know, global warming, global cooling, maybe the Earth covered in darkness for 10,000 years. You know,
as you do. That's life. Get used to it. Get over it.
Crazy, dude. Why do these things keep happening? But it's a crazy good point to make that these things seem to happen in cycles.
Yes.
And like they keep happening. There's probably a huge chance that there were more that happened before the first one. You know, the Ordovician, we were talking 450 million years ago. But once you look further and further back in the fossil record, it's harder and harder to actually get the evidence because all those rocks are getting melted.
Yeah, for sure.
You know?
It's and even that over time, over millions and millions and millions of years, the ground can get subducted once again and take away all of your lovely evidence.
Eaten by magma.
Yum, nice. That's the best Turkish coffee I ever had. But anyway, after the Triassic, see, the thing is, it wasn't as bad for land things, right? It wasn't as bad for land things. It was mostly a marine killer. Yeah. Which was a shame, because a lot of the coral reef building organisms were just making a comeback, and then they got fairly crapped on again. But
why do we always crap on the corals, Andrew?
I don't know. I think it's just like a rite of passage. You
want to be a mass extinction? Why don't you crap on the corals?
Okay, we're trying. But after the Triassic, right, so it mostly was just messing with the marine life. It was bad for marine life. We get into the Jurassic period. And like the Jurassic period is one of the best known ones, because like you have Jurassic Park, and that's awesome. And this is after Pangea has split, and you have these two halves of Pangea. One is made up...
you, Pangea.
Yeah, yeah, Pangea was mean. Like that whole Permian thing was rude. The two parts are, you have the top one, which is now splitting, and it's going to turn into North America and Eurasia. And you have the southern split, which contains all of Africa, South America, India, Madagascar, Australia, and Antarctica. So if you're trying...
Okay, so things we know.
Things we know, like we're getting closer to something we can recognize.
Yeah.
And something, it was interesting. So before Pangea was quite dry. It was quite desert-like, really cold nights, really hot days.
Yeah.
Now, a lot of mountain ranges were made underwater, and it actually raised the sea levels. So much of the land that was dry during the previous periods was actually now, some of it covered in water, and the climate went from desert to somewhat subtropical. Okay.
Oh.
Yeah, and so there was a lot of rain.
I like that.
But it was cool, and like you got these really amazing animals. Now, anyone who's seen Jurassic Park or had a dinosaur toy as a kid knows these, kind of recognizes these things. Like, example animal number one is the Pliosaurs, right? These were the long-necked Mac Daddies of the ocean. They just looked like Nessians. If you ever hear the monster of Loch Ness, that's what we're talking about. Except they were massive, right? They were huge, and they were so cool. They'd swim really quick, and they'd just be with their long necks going out chomping on all sorts. We had giant crocodiles continuing their dominance. We had the giant squids coming out. We had sharks being developed. We had the coral reefs coming back. And there was really cool plankton at the same time that made a lot of the ocean red, which I thought was pretty cool.
That is weird.
Yeah, just, they just had a good time. They were like, let's make everything the color of blood. Keep it up with the theme.
The theme of death.
Fun. Love death. We also had the Brachiosaurus, right, which was present until the Cretaceous period. And the Brachiosaurus is the long-necked Mac Daddy of the land, who was 16 meters tall and 26 meters long. And, oh my god, what's the name of that children's movie that's really depressing about the baby Brachiosaurus who lost their mama Brachiosaurus?
The Land Before Time.
Oh, that's a sad, sad, sad movie.
I don't know, man. For some reason, I have these, like, really nostalgic idea of that. Is that wrong?
I think
I need to go watch it again.
Maybe save yourself.
Oh my god, and Fantasia, do you remember that?
Oh my god.
Bring us back.
Bring us back.
That was traumatizing. There was like all sorts of death going on. I think that goes through the mass extinctions. I think that's really cool. Why didn't we just show that, Andrew? Let's just
copyright
this episode.
Copyright.
Let's just show that.
Oh. Yeah, that'd do it.
Oh yeah.
But like it was in the Jurassic period, we didn't see. The thing is, people get mixed up because of that damn brilliant movie with that sexy Jeff Goldblum, where they show like all these brachiosaurs and velociraptors and T-Rexes.
Jeff Goldblum just just in his prime.
In his prime. He's always in his prime. Don't get that wrong.
Okay.
Where you had the early T-Rexes, which were called Allosaurs. And you also had the first birds, the Archaeopteryx.
Oh, yeah.
The first bird relative that the dinosaurs evolved into.
And maybe let's get the fact sheet right that, you know, most dinosaurs had feathers.
Oh yeah.
Let's remove that misconception right now.
That was
a
us.
lot of dinosaurs
We're the ones
had
who removed
feathers.
it, guys. Just remember that, you know, in case anyone tries.
Jeff Goldblum did it.
It was that damn movie. They had feathers. They couldn't fly. They were like penguins, but they had feathers.
They made that one. That one was great. They didn't have feathers, and then they made like 7 more.
Yeah.
They weren't as good.
And none of them had feathers. Very sad. Though it did have Chris Pratt. I liked Chris Pratt.
Actually, yeah.
The only problem with that movie was like the really forced Coca-Cola in it, where they were like, it just like it was like an ad, and it just broke.
I'm gonna have a product placement.
Yeah, exactly. It was so bad, and it was in the like just at the introduction of the movie, so it just completely broke it up. Anyway, at the end of the Jurassic period, there was no death. How nice is that? That's refreshing.
Andrew, you surprised me.
I know, and we went.
I thought you were going to talk about how they all died.
Not yet. After the Jurassic period, right, we went into the Cretaceous period, you know, and the Cretaceous period, it's like the Jurassic period, but you have the more dinosaurs that you're used to thinking about. You got your T-Rexes, you got your Velociraptors, everything's evolving like crazy. It's all super cool, and that goes on for a really long time. The dinosaurs ruled the crap out of this earth, right? They ruled it and ruled it and ruled it, and then a significantly sized pebble came and tried to destroy the earth and take all of the dinosaurs along with it. And this pebble was significant. It was quite significant. Not good. It threw up so much earth into the sky. It destroyed everything in a certain radius around it. All life forms in that radius. It was like back to opening up Siberia. The earth cracked open. It was like, did you ever see Dinosaur, that old Disney animation?
No.
Well, they basically try to mimic this, and it comes down, and the dinosaurs are just running for their lives, and it was probably similar to that. It was probably mass panic of these dinosaurs that were like, you had like these T-Rexes who, you know, they were in charge, they ruled the roost, and then this significantly big.
The T-Rexes are just running away, and they're like, why are my hands so small?
I can't protect my face from the rocks.
I can't knock off the sweat from my brow.
Oh, so tough. Oh.
So that huge meteorite
Yes.
that Andrew was talking about, that tiny pebble, is about 12 kilometers in diameter, and it made a crater about the size of, I don't know, 200 kilometers. The size of that impact was absolutely huge, dude.
200 kilometers. That's significant enough.
What's the distance from left to right across Ireland, from Galway to Dublin?
About, is that like three?
It's like 300. So it'd be about the size of Ireland.
Oh, well, it's not quite that large.
In length.
In like, yeah, from west to east. It's pretty. Yeah, that's crazy. It's one of those things. I can't really imagine it.
Yeah.
Yeah, everything that couldn't find a little cubby hole to hide in for the succeeding couple 10,000 years had a pretty rough time as they tried to protect themselves from what began as a giant explosion that tried to destroy the earth and ended up with acid rain that would leave marks on rocks and then covered the whole earth in darkness. And then first it was really hot, and then because it was all covered up, it got really cold. So like, you needed to be a really stubborn creature of existence to really get through this one, because like the Permian, that killed a lot of things, but I feel like this was much more active in trying to kill things. It was just the Permian was like, we're going to make the biggest fire that you ever did see, and this was just like, you're taking the biggest rocket.
Fire. I'm going to fling this pebble at the earth.
Yeah, it's a pretty big pebble. It's awesome.
It's huge though, and you know, the idea is that meteorite that hit, that did a lot of damage, and it did most of the damage, but there was
critical
this background
hit.
Critical hit. But the idea as well is that, again, more volcanism.
Yeah.
There's always more volcanism.
Fun.
So most of northern India, much like Siberia during the Permian Age, most of northern India is covered in basalt again, because the Deccan traps in northeast India opened up during the same time frame. So the dinos are trying to get over this crazy meteorite strike that hit the Yucatan Peninsula off the coast of Mexico.
Yeah.
And boiled the water to like 200 degrees and like flung everything up into the atmosphere, did all that stuff, he said. Some bad stuff. And then across the other side of the world, all hell's breaking loose as well.
It's great. Was that a direct effect?
It's one of them. It's one of the ideas is that the time of that province is very similar.
That's crazy.
It's about 66 million years. So it's about a million years different. But the idea is that the asteroid hit, and then after that, the aftermath, and about a million years ago, after, when life was just clinging on, it was like dinosaurs. Yeet!
Yeah, God.
Good luck.
That's scary though, because like, okay, fair enough. If you were a Mexican dinosaur, you were screwed. But if you were on the other side of the earth, you were just like totally fine. Like you were like, grand, this is fine, and then suddenly the entire earth starts shaking, and then nothing happens for about 4 hours, and then suddenly the whole world starts burning down around you.
I was listening to a podcast not too long ago where a professor was talking about when that asteroid hit, and it chucked so much debris into the atmosphere that all of the debris coming back into the atmosphere would have raised the atmospheric temperature to something like 200 degrees Celsius for a couple hours.
Wow.
So the air, I don't understand how that can be, but the ambient temperature of the Earth's atmosphere was 200 degrees for a time.
That's crazy.
How quick would that kill you? It would kill you instantly, right? It would just,
for humans.
A human.
Yeah. Like, how long would you last in an oven? Realistically,
exactly.
like 15 seconds. You'd just be
Open
like, pain! Why won't it kill me faster? And then you pass out from pain, exhaustion, and you die.
Right.
Like, that's, and like, we're only itty bitty things. Imagine if you were a giant. Like that's what really got the dinosaurs. Like, they need all of this oxygen, sweet nectar of life in the atmosphere, and it was gone in an instant, burned up.
It just gets swept away from them. Yeah, that's amazing. And the idea is now that, I mean, that was 65 million years ago, and move another 65 million years to today.
Hello.
And you got humans. They've taken over the Earth, and they're doing some weird stuff. They've completely and utterly used up, as we said in our last episode, we've completely shaped the Earth to our needs. And there's actually questions coming up now that maybe we're entering a sixth mass extinction event. Because, first of all, the studies have shown that the extinction rate right now is about 100 times the natural extinction rate, what we call the background extinction rate.
Yeah.
And if you leave that going for another 500 years, then you're at a mass extinction sort of level of extinction. Then you'll get something like more than 3/4 of the species on Earth dead.
But like, I'm just trying to put that into context, because you were like, oh man, the Permian, that was pretty quick. That was like 50,000 years. And then, there was the big old asteroid, and that was pretty quick too. And then that had more stuff going on, you said, a million years later, and that was somewhat problematic. And then now we're talking that like, how fast is this going on that we're having such a insane extinction rate going on right now? Because like, I feel like if you put it into the context, let's say even over 50,000 years, it's very hard to notice a mass extinction. Like, unless it's an asteroid that hits the Earth, it's very hard to notice life around you dying. Because, especially in our lifetime, let's say we live 70 to 90 years, it's very hard to just take a snapshot of this 60 to 90 years that we personally can look at it and say, right, things are dying, which is quite scary when we're in this time frame and looking at it and saying, yeah, the things are dying really quick. We should stop doing that.
And I think something cool you just gave me an idea that, say we keep doing this for another 500 years.
God help us.
And we push, beautiful sound. Say we push the amount of species down to 25% of what they were when we first evolved,
yes.
right? And it's only over 500 years. And then say a couple hundred more years later, we have a massive nuclear war and humans are gone, okay?
Wow. Okay.
And
I wasn't expecting it to go that way, but cool. Yeah, let's go. I'm getting... I'm leaning back. I'm into it. I'm entering the zone.
Enter the zone. Say 25% of species are left, okay?
Mm-hmm.
And none, natural species, not highly cognitive ability, just your normal stuff, natural environment. They survive. And natural things come back. You get ups and downs of sea level and temperature and global warming, global cooling, all that stuff. Will there even be a record of that crazy event in time because it was so fast in the geological record? Say an alien race came in 20,000 years. Or no, let's push it even further. Let's say in 10 million years, a very sophisticated alien race was looking through the geological record and they were like, ooh, this crazy Permian mass extinction, that looks amazing.
Okay.
But there's no sign of ours in the geological record because 1,000 years is just so quick.
That's true. But, so the way that we normally look at the mass extinctions is that you do things that just don't go away. So, like, you can measure the CO2 levels over the last, 100,000 years by going to Antarctica and, checking out ice cores and, getting the bubbles inside and seeing how much CO2 is in it. But, if there was a huge extinction like that of us, I would expect that the aliens would be like, oh, cool, the Permian, okay. Oh, man, an asteroid hit, cool. Hey, is this an iPhone? Is that... Oh, man. Oh, no, I'm more of a Samsung, dude. I think that even...
they don't get broken down, is that what you're saying?
Kind of. There'd be no doubt that we'd leave a mark. We've already left a mark. The number of cities alone would be almost impossible to completely vanish. Unless the entire surface of the Earth is subducted, I don't see it happening that they wouldn't be able to get a reading from somewhere, because if it's that sudden.
I think what I might do right now is I might just really quickly harp back to the Cretaceous, end Cretaceous, when the asteroid hit.
Yeah.
The way that we know that happened is that the entire Earth was caked in a layer of iridium, which is a slightly radioactive compound, and so you can tell that it's radioactive, and it happened because the asteroid was high in iridium, and iridium's an extremely rare metal on Earth.
Okay.
So that's how they dated it.
That's
they
so
found
cool.
out, what the hell? There's this layer of radioactive iridium.
Yeah,
that didn't come from Earth. That because there's iridium doesn't occur on Earth.
Man, that's nuts.
So what these aliens in 10 million years figure out is they go, and this harps back to our episode about nuclear energy. They go, why is this layer caked in uranium? Why is this layer caked in thorium?
Oh my god.
Why is this layer caked in plutonium? What's going on? And then they go, asteroids.
Yeah. So there was an asteroid that was really rich in all of this nuclear stuff, and bada bing, bada boom.
Yeah, they were like, holy crap, how is it 95% enriched? That's a crazy phenomenon.
Uranium-238.
How are there these asteroids that are like nuclear bombs?
Oh my gosh. That's a scary thought. Why don't we think of something more positive? What animals alive today do you think would survive that? Do you think that there'd just be a master race of cockroaches that assume the same role that dinosaurs assumed after the other one and just become giant rulers of the earth, and we enter an age of little insects that could survive nuclear war? Or do you think there's anything else?
Well, a good point to make about that is that the only mass extinction that really affected insects and arthropods was the Permian.
Yeah.
And that was only because they burned down the bloody forests. So every other mass extinction had a much harder hit on marine species than land species. Yeah. So you can bet that if it's a mass extinction that's human caused, insects will do fine. Yeah. Land plants will do fine.
The only insects that got done by any of those were the significantly large insects. Like, you used to have massive dragonflies that were a meter or two across and stuff, and they were also, like the dinosaurs, dependent on high oxygen levels, and they couldn't really manage it without it. So yeah, I guess a world of insects. Is there anything else? Like, if there was a nuclear war, how would the ocean be affected? Would it just become a nuclear soup, and would everything get crushed and killed, or would we get those three-eyed fish
from Simpsons? Different animals are affected much more by radioactivity. So humans are affected really badly, but certain animals are actually really resilient to radioactivity, and so you have animals that just sit in the sun all day with no sun cream. Like these dinosaurs would bathe in UV rays and they'd be absolutely fine. But I think another positive point to make about this whole thing is that, we are the species that managed to survive. Yeah. And we should be grateful for that. In that, 99% of all of the species that have lived are dead because of all these natural crazy things that can happen on Earth. And actually, and to also talk about, there is one other thing that could potentially be bad.
What?
For humans, and it's that the Yellowstone National Park is a supervolcano.
Ah, yes, supervolcanoes.
So supervolcanoes, like the Deccan Traps, the one that opened up just after the asteroid hit that killed the dinosaurs. Mm-hmm. That was also a supervolcano. Another one was the one that killed everything in the Permian. So there's a chance that Yellowstone could open up.
Well, that's bleak.
The whole movie 2012 is based on that, pretty much.
That is a bad movie, though. So,
it's a bad movie.
If it's not a good movie, how true can it be?
That's right.
Yeah. Yeah, I don't know. A supervolcano is just like, dear Santa, please not in my timeline. Goodbye. It's...
Thank you, Santa.
Leave it to the next guy. The thing that freaks me out about that, right, is that it's the lack of warning, because there's no, they don't have a time span. It's not it's any time from 10,000 years ago to about 100,000 years in the future. Any time will do, it's due. It's like Old Faithful. Yeah, she's due an old pop.
Yeah.
So
and the funniest thing is that so many of these mass extinctions and the geological record, it's so, in our timescale, it's so off. It's like, it happened about 5 to 15 million years ago. It's great.
Yeah.
And all paleontologists are like, yeah, brilliant. Yeah, okay, that's really accurate. And you're like, excuse me, there is a supervolcano underneath my house. What are you going to do, sir? Yeah. Move away from Yellowstone, even though it's apparently beautiful. I've never been.
Oh, it's meant to be so nice because they have the national park there, and anywhere with volcanic activity is just stunning. Like, Iceland is one of the most beautiful countries in existence, and that's even what makes parts of Ireland beautiful. Like Connemara is stunning, and it's all because there were once upon a time a load of granite chucking volcanoes that were like, let's make this place pretty by covering it in rocks, and we're all like, cool, nice.
It's so beautiful.
Nice.
Yeah. Well, enjoy it all while we can.
Yeah. Until the next one comes around, and hey, you never know. Maybe we haven't seen the next big pebble.
The pebbles are fine. There's some amazing technology.
Yeah, you're right.
You're right. Nothing to do with this, but let's just talk about it. There's as part of NASA national security in America and everything, the idea of nuking an asteroid to stop it from hitting the Earth.
I was about to say that as a joke.
Incredibly dumb. The smartest thing to do is to send a very tiny spacecraft to the asteroid and change its trajectory just by the tiniest little bit because of the gravity of the thing that you just yeeted past the asteroid. And there you go. So don't worry about asteroids, people.
Asteroids are fine. Not a problem.
We can just send nukes at them to fly past to change the trajectory of the asteroid.
That makes sense. Okay, that's not too bad. Well,
Doesn't need to be a nuke, but we might as well get rid of them.
Well, you know what, Aidan? This has been a very pleasant experience to appreciate the fleetingness of our existence.
I hope it was positive. I hope it brings you hope.
Hope for what?
The hope is, though, that after the dinosaurs died, mammals radiated. There was a huge diversification of mammals. They finally got out of their dens, stopped eating worms, and started making nuclear bombs, baby.
This is the end of the podcast. We hope that you enjoyed your time. If you're feeling generous and you're not completely skint, why don't you give us some money? Join our Patreon. Join our Patreon. Join our Patreon.